Hello students, in this lab video we will perform the word count lab. So let's get started. So you will be needing a VirtualBox and a machine of the word count. So if you want to get the machine, then you can visit the GitHub link, and this is the link github.com/etslabs/etslabs. So here you should find your word count machine, which you need to download. So here you have the list of all drive links. So you have to pick up your word count. So where is the word count? So here you see this is a word count lab. So if you copy this drive link, and you will get to a folder which has all the machine images file. So when you get there, you will see all these files, and you need to stitch it into one word, one file. You need to combine this file into one. So the way to do it is File Explorer G:. So when you need to download those files, so what you'll be seeing something is like this, right? You will see something like this. So you need to take all these files and combine into one word count file, and this is something that you can import. So the way to do it is, for example, you can first copy this folder, then start 7-zip, right, and paste that folder word count. So here you see one file is there. So ideally the folder that has all these files should not contain your final file. So it's better that this is in a separate word count folder. So you can take this and put it in a separate folder if in case any other file is there. So now it looks clean, and now if you open this folder over here in 7-zip, you should get it, and you can click any one of the file, preferably 001, and click combine. So the moment you say combine, it will ask where you want to combine and save the file. So that time maybe I'll create a new folder called test and use this folder to create the output. So you see it will try to combine all the files automatically and stitch it. So now I will not do that because it's not needed for me, but for you it is needed. So but nevertheless it is going to create, it is already started the process. Some part of the file was created. So I'll delete this file. That file is already there with me, which is this one, which is approximately 8 GB. So so that's how you create a single image file, and you can import this new file using file import appliance. So I'll go to that folder. So G:, it's in my lab. I have saved it over here. So you can take this word count and open it. So the moment you open it, so I'm going to save this in G:. You require at least good amount of space. I think around 20 GB to 50 GB at least should be empty, should be available on your hard disk. So let's finish this, and it will try to create the machine process. So let it start, and in the meantime, so this is how you get your machine. So once the machine starts, we'll start the actual lab. So in the meantime, let's what we will do is we will visit another link and check what are the how we are going to perform this lab, what are the steps you're going to follow. So for that you need to visit bit.ly tcoe student, right? So this link will take you to a BDA folder, and here you should see a lab folder. So by the way, these are all your resources for BDA, subject in engineering colleges, and this is a lab which is part of engineering college, and that's why this video has been created for the engineering students. So you can open BDA lab journal within the lab folder, and here you should find your word count as one of the labs. So let's go to word count. Let me see. Okay, here it is. So lab number 5 in my folder. So let me just zoom it up a bit so that you can see clearly. So as you see, to experiment word count using MapReduce is part of Hadoop, so definitely you require Hadoop, and the word count program is written in Java, so you don't have to write the program. Everything is available. You just need to understand the concepts of how Hadoop breaks up the entire task of counting the words using MapReduce process. So the software that is installed as part are Ubuntu, Java, and Hadoop in this case. And so we will go through these steps and see what we are doing. So first we go inside the HDFS, Hadoop HDFS, which is your file system, and we upload a file. This file should ideally contain all the text, and it will take all this text and basically split it into all words and count how many times that word is appearing in that file. So let us look at one diagram, maybe. So basically this is your machine, right? Ubuntu, which we are creating right now, and in that we already have Hadoop, right? Then Hadoop has two components. One is your file system, right, which you can say it's your, so let's say file system and directories and files. So it's a distributed file system, means it is spread across all. You can have this file system consisting of all files, and save it on a network of computers as if it is one computer. So let's say you have some input file over here, input file. So as I told you, Hadoop, this component is your HDFS, right, which takes care of all your storage, and it stores all your files, HDFS. And the second component is MapReduce, right, which is your processing component. It takes these files and does some processing on this. In this case, MapReduce will process your your input file. It will, let's say this has got x, x, y, y, and y. Then it will read this file, and it will at the end of the process you should get something like x comma 2 and y comma 3. And so remember, this is only one file, but Hadoop can read as many files as you want, and it can use as many machines as much as you have provided. So MapReduce has two processes, right? One is the map process, map task, which we say. So let's write it over here. So MapReduce has got how many tasks? Map task, and the second function that it does is reduce function. So in this case, so this, each one of them is one function, each one of this. So one map task, one map function. So you know the input parameter for this is your x, you know, your all your words. So in this case, you know, you will get your key and value as your input. Value will be equal to x one first time, and so how many map tasks will be created in this? 1 2 3 4 5. So 5 map tasks will be created, and each map task will read that word and give you an output, you know, something like x comma 1, x comma 1, y comma 1, y comma 1, y comma 1. Now whatever is the common key, you know, so I'm explaining you the concept, because if you don't understand, so as I told you, there is going to be 5 map tasks. So let us assume these are the map tasks. So 5. So what's happening? Okay, so 1 map task, 2 map task, 3 map task, 4 map task, and 5 map task. So this is how it is going to work, right? And this is the output. Input will go as x, x, y, 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 something like that, and the output for this will be x. It will count x, one word, one count. Second task will also read x, one count. So there will be 5, at least you know, approximately 5 map tasks that will be created as a part of this process. So it is, and it can run on 5 different computers if there are 5 computers. So that is what the map reduce task will, you know, it takes your one file and distributes and does parallel computing as much as possible at the same time. It counts your words at the same time. So this could be your question in the lab, how MapReduce works and how many map tasks will be there. And now what happens is, once it has counted, you know, 2 reducers task will be created because of this, because there are 2 keys, right? 2 common keys. What are the keys? X and Y. So here you got, why I'm getting this? Okay, let me choose a different color. So 1 reduce task for managing the count of x, right? So this will become your reduce task x, managing x, and the second fellow will be managing y, and it will count all the ones, right? So in this case, this fellow will go to 1 reducer task, and you need to know that all this is happening parallelly at the same time. Once one key gets processed, it is submitted to the reducer while some other keys, you know, map task is running, and this fellow will give you the output of x comma 2, which will be written in the output file, and this fellow will give y comma 3, and this is what is going to be you know, ultimately written in the output file. So in the output file, both of them will be writing in the same output file. So when you read the output file, it looks like something like x comma 2 and y comma 3. So since so where does, so this is the, I know how MapReduce works, it counts the words, but where do we use this? So this could be another question in your exam, in your Viva, you know, where does MapReduce word count is used in real world? In real world, you know, we can read all the new, you know, we can maybe fetch all the news from the world. So this is a little bit of theory going on, but if you understand this, then you'll understand the lab. So all the, you know, your news is coming from here as big data inside the file system, and all the news from all over the world is stored as different files in HDFS. And as soon as it drops in HDFS, MapReduce task takes those files, starts reading them, and creates as many map tasks it is needed, and creates as many reduce tasks it is needed, and keeps giving you the count. So so you can know, you know, by knowing the count of the words, which you know, comment, which who is trending, what news is trending, you know, and so what is the most popular word on the internet, and you can wherever the you want to do the magic of words, your map reduce task can be used to distribute the task and reducing means it's like you're summarizing the results. So here you actually perform the main you can say business function. Your map task is actually doing the main business function, and this fellow is summarizing the data. So you can use this to analyze your data and to do your machine learning. In machine learning deals with data, so you want to execute process all the data very fast, so you use Hadoop MapReduce. So this is how the architecture looks like, and this is what we are something similar we are going to do. So now that we have done this, we get back, and here you see your word count lab machine has been created, and we'll start this machine. So let's wait for the machine to start. So okay, so when you start your machine, you will get this pop-up. You just click switch, and it will give you give you a big screen as big as your monitor. So your machine is starting up. So let's give few seconds to start. Okay, so your machine has started. I want to access those lab instructions from here, so let me start the browser. So you may not be allowed to use the web browser, I'm not sure, so in case, but you need the instructions to perform the lab, at least the steps. So ideally you should be given the steps in your college. So let the browser start. In the meantime, so now that we have understood, we want to start terminal. So we click the 9 dots and you will get this terminal, and we select it and let the terminal start. So if there's any pop-up comes, upgrade pop-up, just close it. You don't want to. Okay, your browser is started, and so in the browser what we want to do is we want to open that file bit.ly/tcoe student. There are many slashes, so that's a mistake. My computer is little slow and I'm typing fast. Okay, so that's the link, bit.ly/tcoe student. So let it come up. It's the same link, and I want to get in the BDE folder. And then open the lab folder. And open the BDE lab journal. Okay, so let's get back to the terminal while this opens up. So let me expand this. And the first thing that you want to make sure your word count is, programs are there inside. So here you see in the right hand side, word count program folder is there. It means this machine is ready for word count processing. So now that we have this, first let us quickly go through the instructions. So what are we doing? We are creating an input directory SDF, as we have already explained you, right? We're creating a local, then we're creating an input folder. In that input folder we are placing our file, my local file, and then we are running the word count program, and then we are checking. So in the word count program, if you notice, we have an input folder and we have an output folder. So input folder, what we have put in input folder, we have put my local file in this case, and it will read the input folder, count the words, and put it in the output folder over here. And in the output folder, it may be part dash r dash 5 zeros, or it may be either it will be this, or it could be the output. Sometimes on some machines it creates with this name, so you have to read that output and you'll see the count. So that's all in this experiment actually. So but the main thing is you maybe asked your Viva to explain the actual program. So your actual program, so we'll so now that you have understood how these things is working, we simply read the file from the input, and then we count the words and put it in the output folder. So your word count program should be in your word count folder itself, right? So I click the file explorer on the left hand side, and then I visit the word count folder, which is down over here, and here you should find your Java file. So your mapper file is here, your reducer code is here. So if you open the mapper code, so let's open the mapper code, and at the same time we'll keep our reducer code also ready. So you will be asked, how does this program work? So here you should be able to explain the map function. So you see line number 31 is your map function over here, and it accepts two parameters, key and value. So as I told you, value means X or Y, or whatever words that is coming in, or whatever lines. In this case, every line is read, so we read each line and we split it into words, and for each word, so there will be as many map tasks as there is and as many lines in the program. So in this case, for example, 1 and 2 and 3 and 4, let's say this 5 line is read, so there will be 5 mapper tasks, and for each line it will split the words and it will count the words. And if you notice, it says word, first of all it stores the word in the string word, whatever word is come up, and then it says context.write. So context.write is the output of your map function. And what does it output? It outputs the key and value. What is the key? Key is the word. In this case it could be X and Y, and 1 is actually the number 1. So even though ON is written, it's actually 1. So X comma 1 is going as output. So now if you go back to the diagram, so that's how your mapper function works, right? It takes splits the words and counts. And but there is how many map functions? We already seen it in the diagram. Just that one map function is created many times to read many lines at the same time, and for every line it splits the words and counts the words and gives output of X comma 1, context.write. And so where does the context.write write to? So map reduce, the way it works is the output is given to, so this is a little thin line, so the output from this goes where? Context.write goes, the output goes to reducer. And which reducer it will go? It will go to the reducer for the particular key, which is X. So for every key, unique key, one different reducer will be doing a job parallelly at the same time. So X will be processing at the same time and Y will be processing at the same time. So context.write in this case goes to reducer, and this could be your Viva question also. So once that output goes to the reducer, what happens? Then the WC reducer function will come into place. And what does this do? This is a reduce function, which is actually a reducer function. In your diagram you've seen there are two functions. So this is the same function which is executed 2 times, but what are the input parameters? Key and you can say iterable, or iterable is like a list, right? List of values. So you will get the same x, but once will be coming in many times. So in the diagram, if you notice, we are sending so this is the value 1 over here, so it's not coming. So this is 1 and this one. So x is a single key, but once there are two times, so two values will come in the reducer function as a list. And what it does is simply sums on line number 16. It reads all the values and sums it on line number 16, and whatever is the sum is actually the total number of how many times that word has appeared. And in the end it does a context dot write. Now even in the mapper function there was context dot write, but in this case the mapper function context dot write line number 20 goes to reducer. But in case of reducer, the context dot write, in what context, who is giving the output in one context, it depends on that. So if the reducer is giving the context dot write, then the output will go to the output folder. So here in the diagram, if you notice, the context dot write will be written to the output folder. So that is how this the map function and reduce function is working. So now that you've understood how this program is running, so let's start with the actual lab. So what is your first step? So in order to use Hadoop, you need to start Hadoop, right? Now do we have that in the steps? I don't know. So I don't think it is there in the steps, so that step has missed. So you need to make sure you start Hadoop. So how do you start Hadoop? There are different ways, but the best way is start dash all.sh if it works for you. So let me put it in blue. So start dash all.sh. After this you want to ideally be inside the word count folder, so you go to see word count folder. So this is not there again. So let me put it in the file, right? So you want to do these two steps first. So how do we, so let's do that. Let's go back and start Hadoop, start dash all.sh. So let's hope this starts. So it's trying to start Hadoop, which will start your HDFS as well as your yarn and MapReduce, everything. So let's give some time for it to start. Okay, so here you see all your name nodes, data nodes, resource manager, node manager starting. Name node and data node is part of your HDFS. Resource manager, node manager is part of your yarn system, and and additionally you have your MapReduce as well. So now since your Hadoop is running, you can perform Hadoop task, like a MapReduce task. So what is your, so as I told you, as soon as you start your Hadoop, first thing you do is go to the word count folder, because that is where you're going to execute here. So here you see we have some files ready to be executed, but we have to create an input file. So in this case we haven't created one input file. If in case if you want to create some input file, for example, so let me first look at the instructions. Right. Okay, so here we want to create a directory inside your what is this? You don't want. Computer is little slow. Hold on. Okay, so let's try copying the command again. So this is the DFS. So if you execute this program for word count, it may execute or may not, I'm not sure, because HDFS is in the Hadoop folder. So let's see if it executes over here. So what are we doing over here? We're going inside the HDFS. This is entering the HDFS, and what we're doing, we are creating a make directory /input. First we are creating an input directory. So let's enter and see whether this works. Okay, this seems to work. Okay, it says file already exists, means the folder is already there. So if the folder is already there, then ideally you don't have to do anything, but you could see the if there are any files in that folder. So how do we do that? So you can use a ls command to see what all folders are there. So since this command is not, let that execute, and so before we execute our word count program, we want to know what all is there in the input folder, because whatever files are there, it will count the words. So and that's why it is important to know what all files exist. So here you see there is already one input file over here, so you don't have to worry about creating this file. If you want to read this file, you can do a cat in /input wc input file, and you can read this file and see what all is there in this. And so let's see what all is there. So here you see there are 1 2 3 4 5 6 7 lines are there. As I was going to say there, so eaves is how many times? One time eaves is here on the first line, then the eaves is there on the second line. So ideally you should get IVs, comma 2, then 7 is there multiple times, that will count to the word 7. Every word is repeated, so you should ideally count this file. So in this lab, since the file is already existing, we don't want to create the file again. So as I told you, so I will put this command anyways for your benefit to read, in case if whatever files are there, in this case the wc input file is there, so you can read it, but if it is not there, it will throw an error. Okay, and this command is actually copying some local file into the input folder. If you have your own file, in this case we don't want to do this command because we just want to count the words, which is wc input file. So what we'll do is, the next command is simply counter start the Hadoop program. So let's go back, and so we are all set to run a Hadoop program. So let's select this command, and now the thing is, the output folder, let's see what is in the output folder. So let's go back, and you can do an ls on output folder, which is like directory listing /output, to see what all files are there. So here you see already there is a file, dash success part -r. So you want to ideally delete this output folder. So if you want to delete the output folder, I have not given you the command, but maybe what you could do, you can just delete the output folder, so that --rm-r/output. So I think this will work for you. Okay, so let's go back into our program, and the command should have been saved here, and copy this command. So we don't delete anything from the input, but definitely output we want to keep it clean, so that whatever output we get, and we click enter. So it has deleted the output folder, and now if you repeat the ls command, you should not find the output folder according to me, or you should not find the file. So there's no such file, and there's no such directory also. You can see the last line, everything has been wiped off. So now you are ready to copy, run your wcount program and see whether it counts your program and how does it work. So we copy this command. So let me clear the screen so that you get to see clearly what is happening. So this is the moment, and so this is the command. So this word count.jar has got everything, right? It is a zip file kind of stuff. It has got mapper codes, your reducer code, and this is the main program wc driver, which will start everything, and it will read the input, all the files in input, which is wc input file, and produce the output of that in the output folder. So let's press enter. So now that I have pressed enter, Hadoop is taking in the program. It has created a job, right? What job it is? So in that job, it's a map reduce job, and it will create a map task and reduce task depending on how many lines are there. In our case, there were 5 lines, so there will be 5 map tasks, and for every unique word there will be that many reducers, and all this will be happening parallelly. So parallel processing is the main one of the key features of so you see the map task is at 0% and reduce task is also at 0%. So this has created a job, and it is creating as many map tasks. It is taking, map is finished 100%, all the map task is done. Now the reducers will be getting the, for different reducers will be getting the input for each unique word, and reducer is also done. So now the thing is, where is the output, right? So your output should be ideally there in the output folder. So we can so do we have a command here to see the output? So yeah, so means you could see what, if you want to. So let me put one more command. So output is created. So before you see your output, you could probably list all the files and exactly read that file. So sdfs dfs dash, this will start your file system, and in that we want to see what all files are there in the output folder. So this is the command. So let's go back and copy that command, and let's clear the screen and paste it. So what do we see in the output? We'll see what all it has created. Remember earlier the file was not there, so it has created part-r-50. So you can read this file by using the cat command. So put cat /output /part-r-50, 1 2 3 4 5, enter. So it is reading that file to see what output. So you see it has created every was appearing 3 times. Your IVIS, we had read IVIS is, actually it has read IVIS question mark as one word, and that's why it is counted as 1. So you can modify your program to take care of any of these errors by modifying your map function and reduce function to make it more perfect. And so this is how your word count works, right? So you can have all the files from the world, and you can give it to Hadoop system, which can manage your big data, a big volume of data, and it can do all the parallel processing at the same time and quickly give you results. Okay, this particular person is trending and so forth. So and so news is so people are typing this word more often, people are searching this thing more often, and there can be so many things that is revolving around words, right? And in science, which particular word is been most popular, which experiments people are talking about in the scientific community and so forth. So having done that, this word count lab is done, and that's all I think for the lab. And with that, I stop this session. Thank you so much, and do well in your lab.